Okay, so in this video, I'm going to show you how to draw the topography lines, the watershed lines, the water flow lines based on the topography lines. So here in this file, I'm kind of same setup from our previous lesson where we drew topography. And this on the right is the version that I copied for the zoomed in 1/8 inch scale drawing. So this is a smaller area, about 2 by 300. And in this area is where I'm going to draw my watershed line. I've just kept the other lines around so you can kind of still see the context of what's going on. But what I want to do is I'm going to use these lines to basically trace out the direction that water would move across this. Pretty simple. I'm going to do that right now. So first thing that I want to do is actually get rid of, well, I'm going to turn these off. First thing I'm going to do is actually going to rebuild these curves. Again, these are my 2-foot contours. And if you zoom in and select them, you can see they're actually polylines because they were based on a mesh. The mesh is just a big triangulated surface. So wherever you contour a mesh, you're going to get a series of polylines that are just segments of straight lines. And so we get a little bit, once we start to zoom in, we get a little bit of sharp corners and a little bit of kind of weird shapes and stuff like that. So we're going to do a command in Rhino called rebuild. Now if I select this curve right here, type in rebuild on the command line, and you can see here I get a little menu that opens and it tells me 2 bits of information. The first is the point count. You can probably tell the point count is just the number of control points that my polyline has. The other number that I get is what's called the degree. So when I draw a polyline in Rhino, just a series of straight line segments joined together, that's what's called a curve with a degree of 1. Basically, there's no interpolation happening. When I draw a freeform curve in Rhino, it's interpolating the curve through the points rather than just connecting the dots. And that is a curve with a curvature of degree of 3. So basically, straight line segments or polylines have a degree of 1, and freeform curves have a degree of 3. I'm going to rebuild all my curves here to have a degree of 3 so that they're smoother and that they're easier to use for my watershed, tracing my water movement. I'll type in rebuild again here with that curve selected. Now you'll see here I have a couple numbers in parentheses, so that's the existing number of control points that my curve has. That's the existing degree that my curve has. So like I said, it's still a polyline, degree of 1. I'm going to change all my curves to have a degree of 3. And I don't really want to lose information or lose that much information about the shape of my curve. So the number of control points is also important. I'm going to try and keep it just about, doesn't have to be perfect, but just about the same number of control points that it has. So I'll change that to 12 as well. Now you can see we have a little bit smoother of a line. You could also, you rebuild it with a fewer points. You'll notice that when Rhino rebuilds curves, it also evenly spaces the points, more evenly distributes the control points. That'll also smooth it out. I'm going to go kind of one by one here. Oops. Now I'm going to redraw these curves, rebuild these curves, a similar number of control points. I'm just checking it out. We'll go like, 20, few less, I guess, to make it a little bit smoother. There's actually have a lot of control points. And go like that. You can also put your little mouse in that box and use the scroll wheel. And so I'm just hitting enter to repeat the same command. Next curve, hit enter. And the scroll wheel to adjust the numbers there. That one I feel like could be a little smoother maybe. We don't want to lose a ton of definition, but I think when you see things like that, they're kind of jagged like that, probably just because, the curve was a little bit not smooth. You can also, if you let it sit for a minute, it'll actually give you a little preview there. What the curve will look like. That one's, there we go, it's a lot smoother. Okay, I'm going to finish doing this. I'm going to finish doing this, and then I'll come back and show you how to do the trace the watershed. Okay, so I've rebuilt all my curves so they're smoother. You can see they're now curves with control points rather than polylines. And the next thing that I want to do is trace out my watershed. Basically, I want to know where would the water flow across the surface, in what direction, and how does it kind of coalesce as it flows across this surface. And the way I'm going to do that is I'm going to simulate kind of what rainfall would be. So imagine we have a rain shower going on and there's water, kind of an even amount of water falling across this whole surface. We're basically going to draw like a grid of points over the surface, and then we're going to trace from each point kind of downward along the slope and trace out how that water would move. Now I've made a new layer here and it's called watershed. I'm going to change the color of it so we can tell it apart from the rest of the lines. And I'm going to draw a point in the command point, and I'm going to place it at the bottom left corner of my rectangle. Just snapped corner. I'm going to grab that point and I'm going to type in array. Now, array lets me copy things kind of in multiple dimensions. Allows me to take this point and copy it into a grid. Now my outline is about 2 by 300, something like that. So I'm going to do like kind of a 2 to 3 ratio here. Now the x direction is this direction, the long direction, or the this direction of the rectangle, and the y direction is the vertical. So I'm going to do like, I'll start with, let's say 12. And then in the y direction, I'll do 9. In the z direction, I'm just going to leave it as 1 because we don't want to copy it vertically. And this part, we're going to try and kind of get close. It doesn't actually matter too much. I just want some points that are going to be like in our rectangle. We could go to let's go to like closer to the outside edges there. And by the way, I'm holding Alt on the keyboard to temporarily turn off object snaps. You can also toggle that, just hitting disable them. That makes it a lot easier to kind of click in a very specific spot without snapping anything. I'll click right there. It's going to ask me if I want to accept that. So I could still make adjustments to the number I have, like if it didn't seem like it was square grid, if there was a bunch more in one direction than in the other. Or if I wanted to change the density to more or fewer points, make adjustments by just clicking on any of these and re-entering the numbers. And I'm pretty happy with that, so I'll press enter. Now, before I do anything else, I'm going to type in the command select, SEL, last. Select last. That will just select all of the points from the last operation that I did there. And I'm just going to group them because that's going to make them easier to select later. You could also use the command select point, LPT. That'll select all your points as well. I'll just type in group. And now all I got to do is basically trace the watershed. So one of the things that useful here is that one of the reasons I kept these other lines and that I still want to keep my 3D surface to refer back to, and you guys will all be familiar with what's the actual direction of the topography, right? I believe this is the low point and this is the high point. This is also kind of a high point. So I think for the most part, our topography is going to kind of funnel water towards this corner of our outline, but I'll just double check on my 3D surface here. Off maybe. Mesh edges, okay. Shaded. So it kind of looks like that, yeah. I'm looking at it from above. I think that's our high point. A little peak to one side. You always just move this rectangle up. I'm going to copy it. Rather than do that, I'll turn on Gumball down here at the bottom. This is another quick option for moving stuff and dragging stuff and rotating stuff. I'll turn that on and just drag it up in the z-axis above my surface there. So it's a little easier to tell where in there. So yeah, so we can kind of see that's kind of a high point. Those are kind of high points. That's kind of a low point there. Okay, so I'll throw it back in top view. You can type in top in the command line, or you can right click in the top left corner of the viewport and go to set view. Top. And I'm back over on my topography here. So basically I'm just going to draw interpolated curves. Now this is the command that's under, click on the little corner there. Interp curve. You can also just type in an interp curve in the command line there. I'm going to stay on the watershed. The other thing I'm going to do is first I'm going to turn my O snaps back on. Then I'm also going to turn off all the types of O snap, object snap, except for perp, which stands for perpendicular. Sorry, I want to turn on end just to get it started. No, sorry, not end, point. I'm going to start basically each of my lines at one of these points, right? I'll turn on point just to snap to that point, and then I can turn it off. I can turn these on and off while I'm in a command. I'm also going to turn off Smart Track. That's going to go away. But so I just want this object snap turned on, none of the other ones. The reason being is that that's the one I'm going to use. I'm going to draw a line through the perpendicular points. Time it hits a contour perpendicular. What that does is it's not perfect, but it kind of simulates the direction of water flow, of the slope of our site. Because you know, water tends to flow. So this is one area where I'll just draw it out and click. When I'm done, I'll press enter. But the reason being is that water flow tends to find the fastest path, easiest path, the part of the path with the highest slope. From over here. And so we can pretty much say that any point that's, you know, perpendicular. Oops, I ended that one. Turn it over. But basically, any point that's, you know, like the area where the steepest slope is the shortest distance between two contour lines, which are basically perpendicular points. You might end up with some areas like that, and you will notice these lines have a tendency to kind of coalesce, to come together, which is exactly what happens when you draw, sorry, when water actually hits the surface. Another one from here. So it's not perfect. It's not exactly what water would do on this surface, right? It's close enough for our purposes, and it allows us to visualize, you know, how water is going to move, where the more dense areas of watershed are and where the less dense. I don't know why it won't. I'm just not hitting it at the right angle, but I'm just going to go kind of down here and off page. And it also makes quite a nice. And so you can choose the density of points that you want. It's up to you, but I think that the more points that you do, the kind of better you'll be able to see. Now, that kind of thing might happen. Once I click the third point, you'll see that it kind of starts to even out, but we could always go back and adjust it so that we don't get too many overlapping lines. All right, so I'm going to go ahead and trace the rest of these, and then I'll come back and I'll show you what the final looks like. Okay, so that's roughly how your watershed lines should look. You can do more or less depending on your topography, and but the idea is that you'll get a sense of how these movement with an even distribution of water will sort of coalesce across the surface of your site, and that can then be put on another layer, and you can use that as the line weight as a kind of diagram of water movement across your topography. That's going to wrap up this video.